Hello, everyone. Uh, I'm really glad we are here together today. We'll talk today about the concurrency in React lifecycle, and the presentation is split up in two parts: the parts for everyone and some functional things, and for advanced users, for whom for those who are interested in this, and some like architectural stuff here. So first of all, why do we really need to be aware of concurrency problems, and what is it about, and where exactly it can happen, and what is the simple solution to this problem? And next, we will talk about how React is not reactive and why should we keep this in mind while we design our application, design our components, and so on. And next, we will talk about clean architecture and how it helps us make this happen. So let's begin with the reason behind those problems. And the concurrency obviously is a side effect of render optimization. If you know about React render, you may have probably heard about this, but I would like to pinpoint the problem and this how it really works, and what can be done and how it can be avoided. So a brief overview of how it happens. So React is trying to render and mount components as soon as possible. Please keep this in mind, because it's really really necessary for everyone to understand that mounting components as soon as possible is crucial in React, and we want to see something as soon as possible. So this is a side effect. Next, the component is mounted before the previous one is destroyed, and component will unmount is executed. So yeah, it can be called before, but executed after. So when we mount a component, we create it, and we run an initial render. And this happens before the component is destroyed. So before the component will unmount is executed, we need to have new component ready for it. And this means perfectly component mount, and component will unmount should not have any asynchronous operations inside, like async await, promise then, and so on. Why so? Because the order of execution is different, and we can really break some things, because you could think about concurrency between components, or sorry, between promises, and the concurrency was in the components itself. And next, that's why you don't place any of them in the constructor as well, because constructor is called before the unmounting, the component is unmounted. Let's see how this is going, and I think it's a trade-off. We want things to be quick, and then it's the concurrency appears as a side effect, and it's really a trade-off. You need to follow those rules. You need to see those, understand how it works, and avoid some architectural things about that, and everything will be okay, but it will be quick. So as you can see here, the unmount is called before the mount is called. So the component is called before, but as soon as you call mount, you create the component. And the creation of the component, it assumes that you have to render it, you have to prepare it to be inserted inside the virtual DOM and then inside the DOM. And then after the component is ready, we run the component will on mount, it's running, it's executing, then you replace DOM node, and after that, only after that, the component mount is happened. So let's see what we have here. So first, anything action like promise may be resolved after the component is destroyed. I think everyone knows this perfectly because I guess everyone had this error when you're updating component state after it's destroyed, and React says that you are doing this on mounting component and something like that. But also, component will unmount is executed after the initial render. What does it mean? It means that all use memo, use callback, use reducer hooks have returned their values by this time. So they were executed, and the functions inside were executed, and the result was memoized. And it is crucial because sometimes it can be like this: you're creating some entity, and the function you are calling creates some things, and for example, it calls an asynchronous action inside, and you know what can be there. So you could have like promises and a lot of stuff here. So, but let's stick to this thing, to this scheme, and just remember that use memo, use callback, and use reducer are called on initial render and before the previous component is unmounted. Next, let's remember advices you've got. I got those advices when we were just studying React, and for example, Redux, why Redux is designed like that, because don't use component state and rely on props. It can be really annoying thing, but the reason behind it is that when you're unmounting components, you can also change state, and it's not what you want there. Don't keep any logic inside the component, because you can really have a lot of things, and you can make the component less maintainable. And I don't know. I think most of you knew about this already. Keep track of the life cycle, make it straight and simple, and because if it's not, there are probably problems, and you want to rethink of how to do this, refactor this. Like if you check a lot of things in the lifecycle methods, then maybe redesigning the component is the better solution in this case. And of course, optimize your renders using should component update, minimization, and immutability. You don't want to your application to be re-rendered every time you got some updates. You want to stop rendering when it's not necessary. But one advice I've got when I was studying React in 2015, and it's avoid calling promises inside the component call process. Just remember that promise is just the rails for asynchronous logic. I know that this is not about the concurrency itself, but it is connected because the concurrency, asynchronicity, and something like that, they're all connected. And if you have promises inside the component, you're just making things more complex most of the time than it could be. So the result value of the promise. So when promise is resolved, the result value should be passed into the component as pure as possible. Ideally is a string, but it's more about how you represent things, but definitely not promise string. You don't want promises to be inside the props. And represents your component state, not the state, but how it looks, visual state, like pending requests, errors, etc. As simple as possible. Ideally is a bunch of booleans. I know some people could say, okay, we have monads, but we are not talking about functional programming right now. For people who don't know, who know nothing about monads, a bunch of booleans will do, really. Like loading true, loading false, it will do. You don't need to wrap it with some structures. So this is how it should work. You should calculate everything outside the component, provide changed props inside. Let's see the picture. So you remember this. And this is how it should look like generally. So you're calling get something on component.mount. It goes somewhere. There some async magic happens. We don't really know what really happened there. For the component, it's like you called something. You may have not called something, and eventually you've got some updated props. Nothing more. So this is how it should look for the component, and this is really the magic for this component, because no, you know, new props, they just arrive, component update is called, and voila. So let's take a look at a real life example. We've talked about how it's working, and this advice to avoid promises, it's really it really helps, because most of the time, really most of the time, you don't need to take care about concurrency. There are cases where you have to, and I will talk about this real life example. It started the idea of this particular presentation because what we wanted to achieve. So we have some application sections. They use WebSocket data. We have a single WebSocket and different sources on the backend, and some of the sections get data from the same source, but with different set of parameters sent to the server. So, for example, we want quotes for EUR/USD on one section, and we want quotes for GBP/USD on another one. And the symbol is a parameter I want to send to the server. So first, we need to unsubscribe from messages for the previous section. So we are sending unsubscribe from quotes, and then get subscribe to GBP/USD. And for this, we use lifecycle events, because really, it's the only way for us to know that this component doesn't need this subscription anymore, and the new one wants another subscription. So it's a perfect time for calling those messages. And how it actually worked. Sending message to the socket. returns promise. It's how the library is built. It returns a promise, which resolves on receiving message from the server. It's like a standard REST API. You HTTP protocol. You send message. You receive a response, and the promise resolves. But over WebSockets. So message forward, message backward. They are connected by an ID, and that's it. We can't unsubscribe from the parameter set. We can just completely stop the message flow from the source. So we unsubscribe from quotes completely. We need to resubscribe for the new set of parameters, and then unsubscribe back from every quotes, and then resubscribe for the new parameter set. The promise to unsubscribe, it actually how it was. The promise to unsubscribe will be resolved after the new component is subscribed. And this is where everything started to work like this. Data flow for the new component was abruptly stopped by the previous component. So the previous component finished its life cycle, and the last thing it called was a promise to unsubscribe. Really, we spent a lot of time trying to find the root of this problem, like a week, trying to solve. Sergey is here, and he remembers how it was, and we were trying to solve this together. And
Alexander, can I have a quick question here? So just to make sure that I understand the problem correctly, you said that your next component, which subscribes to a new quote, would not render until the previous one unsubscribes from the previous quote.
No. The problem was that new component sends subscribe, and it resolves before the unsubscribe is resolved from the previous one. And that's how you're subscribing on both. I will show you the pictures, and you will understand how it works.
Okay.
Yeah, this is about that avoiding promises in the component is not enough. I know that we were working with promises in the life cycle, and because we didn't have any choice at this time. And actually, using asynchronous component in mount, component will unmount helped us find the cause of this and the possible solution. So sending the request, just sending to the request to unsubscribe wasn't enough as well, because it's still if you unsubscribe, send this in the same order, it still will unsubscribe after the new one is subscribed. So the new one is subscribed, and then unsubscription abrupts the flow. And server stops sending data right after the unsubscribe request is completed. We needed a queue. We needed to be sure that the promise to unsubscribe from the source is resolved before the subscription is started. So we needed to wait until this happens. So in terms of pictures, we wanted something like this. We wanted to call unsubscribe and call subscribe, and be sure that unsubscribe is resolved before the subscribe is resolved. So first call, first resolved. In manner of speaking, it looks like this. So if the subscribe takes less time, it waits until the first one is subscribed. And we were trying to find the solution, how to do that, how to elaborate this problem. So what we had something like this. So we call unsubscribe, we call subscribe, and eventually unsubscribe resolution happens later than the subscribe is resolved. So it breaks any sent messages, because the WebSocket is a single stream of messages, and we send subscribe, and then we sending unsubscribe to the WebSocket. This is how it works, and it was not working at all. So there was a situation like this. We were subscribing at construction and unsubscribing on mounting, and that's how we really found out that the construction happens before the component will unmount is called, because the illustrated situation happened. And what we eventually got when we used the queue. So we are calling unsubscribe, and it's the request is started. Then we call unsubscribe and wait until the unsubscribe is resolved. And then after it's resolved, we start executing the subscribe promise. So just compare with the picture on the right on the first lane. They are different, but the last one is more realistic, and it was really easy to solve. So let's get detailed. So the solution to the problem was that the queue was built on promises, obviously. To put a promise in the queue, you just need to call them on it, and the promise you're putting in, you put in the queue, it won't be called until the previous one is resolved. So to keep the architecture of the components clean, the queue operations were wrapped in the void function call, and that's how it looks like. I know it's not pure because we have a side effect, we have a queue outside, but this push is really a way to avoid the concurrency in between components. Then unmount, they can happen at different times, and this queue, it keeps the principle of every promise is resolved in the order they were put inside the queue. So in which order they were called, in that order they will be resolved, but they will wait for the previous one to be resolved first. I know that this could be made something different, but that is the idea. That's how we solved this, and the idea of this presentation started, and then I understood that, all right, concurrency is okay, but we are using some things here, and not everyone understands why we should use or should not use streams or like that, and how it really helps. Because promises are okay, but as you could see, they can really create a lot of mess in your code, and React doesn't like promises at all. What else can we do? So I said that React is not reactive. And probably most of you heard about this, but let's refresh the thing. So what is it in the React is not reactive? So ideally, if it was reactive, the props would be an observable you can subscribe on. So you change props, and observers are updated. The component is an observer, and you just subscribe on props. And the actual UI render, so the operation is DOM, is the effect of the next function of the subscriber object. This is how any of streams work. So you can subscribe on stream, and whenever something is changed inside the stream, the next function is called, and this all things happen. What we actually have, the component is pushed to render stuff, so you have to generally say that render this and render that, and you have to keep track of things. You need to sugar your components with high-order components or hooks to be able to subscribe on values. So you cannot just get your React working. To trigger the update on the component, you have to use component state or use some kind of dispatcher, like in Redux. So the component state is, if it's simple, if it's on primitives, it's okay. But for objects, is not as okay. So keep that in mind. And this brings potential problems with concurrency, like trying to update state on the unmounted components as well. And sometimes you can forget some things, like something. And while you are getting something, something could be changed, and it's complicated. I don't want to get too deep into this. So first step to solve the problem, because React is not reactive, we need to separate data acquisition, the actual subscription, from the UI representation. Remember what I said about the component state. Let's separate the state from the UI component. So we don't use the state for the representation. The component is content, and it's using only props. So we need to somehow separate the data acquisition and this thing with the components. Like, okay, some kind of dispatch or something like that. We need to subscribe on an atomic subject, perfectly a primitive collection item. Collection item, it's okay if it's changing the reference. You don't want to change the contents, you don't want to mutate it, so it's okay, it's an atomic subject. And if you want to read some more, you can just Google signals in terms of front end, in terms of React, and you will get this information and get more deep inside. Then we should minimize our code and be careful with the dependencies. Really, dependencies is a big deal. If you change your, if you mutate your object, or the reference has changed but object didn't change, it can start or not start when it should be, some updates, and really be careful with the dependencies. Try not to rely on objects, rely on values. So ideally your dependencies should be like properties you get, or if there are items or what you're creating, rely on values. There are some exclusions, but most of the time try to rely on primitives. And design your UI component so it's independent from the way you get the data. Just if you know about Solid, remember the inversion of control principle inside, and make the component like you can get this component and use in some other application with different API, with different types, with different everything. And you can use it easily without changing at all. So design this component like this. So it's unconnected to even to your models you're using. Try to separate the representation from any data structures you have inside. This is just a representation. And in order to simplify the memorization, stick to the primitives in props as much as possible. So, or collection items. So don't pass a lot of stuff inside the object, because the memorization likes primitives because you can just compare to two strings and it will be okay. And if you have objects, you will either check them completely because they can change references and not change the contents, or you're comparing just the references, and you will have re-renders when even if it's not supposed to be rendered. So next, after what we've done, we still have some problems. So we want some of our props to be the result of users' actions, like controlled inputs, and it's okay. We want our component to keep track of the promise state, like pending, success, error. We want, when we acquire some data, we want the component to display that it's waiting for the response, it got response, or there was an error, and we want to show this to the user. And the third one problem, we want our component to also receive the data from the WebSocket. Just imagine a data table with a filter. The component, the UI that has all those problems. So we have filter, like it is a control input, and we have some data loaded, and some data is updating with WebSockets. Okay. So for this all, we have a single solution, and it can be useful if you already have some problems. So first, abstract from the way your component gets props and create containers. Remember what I've said before, that you want to separate your data acquisition. The containers is one of the ways to do that. So you create the containers, and it's working as a medium. Make the UI component render what you said and be pure. Like you are calling it pure in terms of functional programming. You're calling the component with the same props, and you get the same result every time. The component should just trigger the events. Events, like this is the only way to communicate with outer space that is outside the component. So we need to pass the triggers inside, and this is the only way how the component is communicating outside. In that way, user input, promise, data, and state, data from the WebSockets, they are both equal. Because something is happening, something you get something, you don't know where you get it from, and it's all just rendered. And the event triggers are equal as well. And if you treat component mount as events, you will not have any conflicts here. The component is mounted, it says that it was mounted, and the React engine says that it was mounted, and it calls component mount. You have your handler there, and you can pass handlers inside and call data acquisition, for example, when the component was mounted. Don't expect anything else from it. These are just the event handlers. And use signals to keep the state, because most signals are just observables. And if all the data is inside the observable, you can subscribe on it. It doesn't really matter where did it come from. It can be from the REST API, it can be from WebSockets doesn't matter. So remember this image, and that's what we have here. We just concretized the container, and somewhere else we still have some async magic here, but we structurized the interoperation between the component, container, and how it's working. And user input, it just happens, and the container returns some new props to the component is updated. So this is basically what you can have to help yourself avoid things.
Hello.
Okay, so the component is a compliant object happy to display what you got. Remember this. And the container is a medium between the component and the business logic entities. You don't want to be like, you don't want to be too particular here. It's just like that. But what about clean architecture? Yes, it saves the day because it's designed to follow this described solution. You have your UI, displays what it was set to, the container reads view models, provides props to the component, view model gets services and stores to return a bunch of items. I think you've read this. Let's keep to the some graphics. So here we have component, container, view model, and service. We don't want to see anything behind the service because we don't really need to in this case. So everything starts with the container mount. So we create the container, and it's called. It's basically a functional component, and we need to create it, and we need to get some dependencies, and we create services if we need to, or we get them from the dependency injection. We use it to create view model, or we use it from the dependency injection. Then the results from view model, we generate some props and pass them to the component, and then the component is mounted. And after it's mounted, the container is also mounted, and the component did mount function or use effect function is called for the first time. Then we start getting data. The get data is a function from view model, and view model knows that to get it, we should call two different functions from the service, and then some async magic happens again because we don't want to get too particular inside this. And eventually, after the response arrives, we stop here on this red dot. So what happens here? Here, we update an atom. And because it's the observable and container, when it was creating the view model, it subscribed on this atom. It gets this update. So why it's green? Because here, nothing happens in the chain, no calls at all. It's just an asynchronous call, it's just event loop, and your container gets an update. And then we update the state, the container updates itself, it updates new update props, gets an update to the component. That's it. What about user input? The same. We have a handle input from the view model. View model is called. Here we have the same signal. Maybe the same, maybe not. And still we get the update and new props. So this is it's not as different from what I've showed you before. We just concretized this somewhere else with view model and service, and still we have some async music. Basically, that's it. My two advices: don't use promises. Keep track of your architecture. And the last thing, if you really need to straighten up your promises, use the queue. I will return to the code. You could have a screenshot of how it's working. It's really simple. That's it.